Today is the last day in section 4.2, and the objective for today is to use the periodic properties to find the value of any given trig function. So in your notes, we're going to label periodic functions. And we're just going to discuss the period of each 6 trig function. And when I say the period, it means the distance for one wave to be completed. So the sine and cosine functions have a period of 2 pi. So what this means is if I have sine of an angle and I can either add or subtract 2 pi, it's the same as sine of the original angle. So remember that whole idea of like coterminal. This just allows us to get the angle to be a little bit smaller. So the objective of this is that I'm going to give you any given angle and I would like to know the trig function. So instead of memorizing everything, we just memorize those key values from the unit circle, and everything will always bump back to one of those values in the unit circle. So this is also true for cosine. If I can add or subtract a revolution, that means the answer is the same as that original theta. This is also going to be true for secant and cosecant. So again, their period is also 2 pi. And I can write this as secant of theta plus or minus 2 pi equals secant of theta. And if I have cosecant of theta plus or minus 2 pi, that's equal to cosecant of theta. Now tangent and cotangent have a different period, so that's why I grouped these 4 together. So I'm going to go to the next slide to show you tangent and cotangent. So tangent and cotangent have a period of pi. So that means if I have tangent of theta and then plus or minus pi is the same as tangent of that original angle. Same thing for cotangent. So if I get to add or subtract a pi, it's the same as the original. And again, the goal is to kind of always get everything to come back to that first quadrant if possible. So for our first example, again, the directions are going to say use the periodic properties to find the value of the trig function, and that was our objective today. So they want you to find sine of 9 pi over 4. So again, this is going to be one of those moments where you should have your unit circle handy. If you don't, pause the video and grab it. Notice 9 pi over 4 is not on your unit circle. So again, just like when we did the even and odd, we used that negative rule. I need to get this angle to be smaller so that I can figure out where it falls in the unit circle. So since it's sine, I need to take away a 2 pi. So dealing with just the angle alone, removing the trig function from this, I need to take out a 2 pi. Because 9 pi over 4 is too large, so that's why I'm subtracting it, not adding it. Need to get common denominators, so I'm going to multiply this by 4. So 9 pi over 4 minus an 8 pi over 4 is pi over 4. And based on this angle, looking at your unit circle, the coordinate is root 2 over 2, root 2 over 2. And now the last part of the problem is, since it's asking for sine, I know sine is y over r. I know the radius is always 1 from the unit circle, so the y part of my coordinate is root 2 over 2, so my answer is root 2 over 2. So again, it's just kind of like what we did before, but building upon it, adding in that extra step. So let's try another one. So this problem is tangent of a negative 5 pi over 4. So now we're going to bring back those even and odd rules from the beginning. So when I have a negative tangent, the rule says that the negative goes out front. So the first thing we're going to do is move that negative out front. So now I'm dealing with a positive 5 pi over 4. Now 5 pi over 4 is on your unit circle. However, you don't want to have to memorize all the coordinates. If you can just memorize everything from the first quadrant, this rule will kind of help us get us always back to that first quadrant. So I'm going to take my angle 5 pi over 4, and I want to take out a pi because the period of tangent is 1 pi. And to get common denominators, put this over 4. So 5 pi over 4 minus a 4 pi over 4 leaves us with pi over 4. And again, the coordinate from that is root 2 over 2, root 2 over 2. And tangent is y over x. So I'm going to take the y value divided by the x value. However, there's still a negative out front. So I have negative root 2 over 2 divided by root 2 over 2. And since I have exactly the same thing top and bottom, you don't necessarily have to multiply by the reciprocal. I just know they're both going to cancel. And negative 1 would be my final answer. So that's all for today.